Did you know that the universe might have made its first galaxies faster than it made its first stars? Sounds backwards, right? But hang on. What the Webb telescope just found might force us to rethink everything we thought we knew about cosmic history. All right, story time. Back in 2022, not that long ago, we thought we had a pretty good grip on how far back we could see in space. The reigning champ was a galaxy called GNZ11, spotted by the Hubble Space Telescope. Hubble, with its 2.4-meter mirror, had been our trusty cosmic time machine. But as powerful as it was, it had its limits. The really early universe, just too dim, too stretched out for Hubble to handle. Then came the Webb telescope, and this thing came into play. With a giant 6.5-meter mirror and eyes tuned perfectly to the infrared, exactly the kind of light ancient galaxies give off, the Webb telescope started smashing records like it was in a cosmic Olympics. In its early missions, it discovered a galaxy named GSZ 14-0, aka Jade's Galaxy, with a redshift of 14.32. And just to make sure we're on the same page, redshift is basically the universe's way of showing its age. The higher the redshift, the older the light. So, yeah, this was big. But wait, it gets better, because the Webb telescope then spotted another galaxy, MOMZ14, with an even higher redshift of 14.44. That means we're now seeing light from just a few 100 million years after the Big Bang. Think about that. We're basically peeking at the universe's baby pictures. Now, here's the part that made astronomers do a double take. MOMZ14 is tiny. I'm talking only 500 light-years across. Our Milky Way, over 100,000. But despite its size, this galaxy is bright, like way too bright for something that's supposed to be from a time when stars were just starting to get their act together. And here's the real twist. There's no supermassive black hole at its center. Normally, galaxies that are cranking out stars like a factory have one of these giants, helping to control the pace of star birth and structure. But MOMZ14? Nothing. It's just doing its own thing. And just when astronomers thought they'd seen it all, the Webb telescope's spectral data showed this galaxy was rich in nitrogen. That's kind of nuts, because nitrogen usually means there's been some serious star formation and chemical recycling. In other words, this little galaxy is far more evolved than anyone expected it to be this early on. Galaxies born this early in the universe? They're supposed to be basic, like bare bones, hydrogen and helium basic, but MOMZ14? Yeah, no, this little firecracker is anything but simple. Its light carries the chemical fingerprints of multiple generations of stars, meaning stars were born, lived full lives, exploded, and enriched the galaxy before MOMZ14 even came into being. Let that sink in. We're talking about cosmic recycling happening way earlier than anyone expected. And that leads to a big question. How many more like it are out there? Before the Webb telescope, astronomers assumed galaxies from this early era were incredibly rare, cosmic unicorns. But now, they're showing up more often than we ever thought possible. In the Webb telescope's deep sky surveys, these compact, blazing red objects, sometimes playfully called little red dots, are popping up all over the place. MOMZ14 might be the current record holder in terms of age and redshift, but let's be honest, it probably won't wear the crown for long. Because here's the thing. The more we look, the more we find. And every new discovery is like a chisel, slowly carving away at our long-standing assumptions. If galaxies like MOMZ14 were already forming stars like crazy, were richer in elements, and more evolved than our models allowed for, what else have we gotten wrong? So yes, MOMZ14 doesn't just raise eyebrows, it throws a wrench into our entire understanding of early galaxy formation. Our current models say early galaxies should be rare, sluggish, and chemically simple, but MOMZ14, it's the opposite. It's energetic, complex, and punching way above its cosmic weight class. Now, that doesn't mean we've got everything wrong, but it does mean our cosmic puzzle is missing a few key pieces. MOMZ14 is one of those pieces, a hint that the early universe might have been a lot busier, faster, and richer than we imagined. And guess what? This is only the beginning. Later this decade, another space telescope, the Nancy Grace Roman, is joining the hunt. It'll scan huge swaths of the sky in ultra-sharp detail. Paired with the Webb telescope, this duo could uncover hundreds, maybe thousands of galaxies like MOMZ14, each one a time capsule from the universe's earliest days. But for now, MOMSY 14 holds the spotlight. A tiny dot of light from a time when the universe was still learning how to be a universe. Yet with each data drop from the Webb telescope, the cosmos keeps pushing the boundaries of what we thought was possible. Some scientists now believe that the behavior of these galaxies might point to something massive, like universe-shattering massive. One recent study found that an oddly high number of galaxies all seem to spin in the same direction. Strange, right? In a truly random universe, you'd expect a 50-50 split, half clockwise, half counterclockwise. But that's not what we're seeing. This unexpected pattern has led some researchers to entertain a bold idea. What if our entire universe is actually inside a black hole? Stay with me here. When matter collapses into a black hole, it creates an event horizon, a boundary where nothing, not even light, can escape. What happens beyond that horizon is still one of the biggest mysteries in physics. Some theories, part of what's called black hole cosmology, suggest that what's inside a black hole could look like an entirely new universe, one with its own space, time, galaxies, and physical laws. So when we see strange rotational patterns in galaxies, when we find ancient, chemically advanced galaxies that shouldn't exist yet, maybe these aren't just weird flukes. Maybe they're clues. Clues that the universe is not only stranger than we think, it might be stranger than we can think. But what if our entire universe is actually inside a black hole? Yep, it sounds like science fiction, but it's a real theory, and it's called Schwarzschild cosmology. Let's unpack this. Imagine for a second that the Big Bang, that explosive moment we all learned about in school, wasn't actually an explosion in empty space. What if, instead, it was the inside of a black hole, forming in a much larger, older universe? That's what this theory proposes. See, the standard model of cosmology says the universe began from a singularity, a point of infinite density. You know what else has a singularity at its core? Yep, a black hole. So here's the twist. What if the Big Bang wasn't the beginning of everything, but rather the birth of our universe inside a black hole in some parent universe? Not an explosion, but a kind of cosmic rebound. And it gets crazier. If this theory holds, then every black hole we see in our universe, from the ones at the hearts of galaxies to the stellar mass ones born from collapsed stars, might not be an end, but a beginning, a doorway, each one possibly spawning its own universe on the other side. Kind of like cosmic Russian dolls, universes within universes. Now you might be wondering, why does this idea even matter? Well, aside from being wildly cool, it could help explain some big puzzles, like why the fundamental constants of physics seem so perfectly tuned for life. Gravity, electromagnetism, and the strength of nuclear forces. It's all just right. Coincidence? Maybe not. According to this model, only black holes that generate stable, long-lasting universes survive and go on to reproduce more universes. So, over time, universes that work stick around, kind of like natural selection, but on a cosmic scale. The ones with chaotic physics, or unstable constants, they vanish. It's like evolution, but for entire universes. Let that simmer for a second. There's more. Black holes have something else that ties into this theory: immense entropy. That's a fancy way of saying they contain a ton of information. And guess what? Our universe also contains a staggering amount of information, from particles to energy fields to space-time itself. Maybe that's not a coincidence either. And then there's torsion, a concept from an extension of general relativity called Einstein-Cartan theory. It adds a twist, literally. In this framework, space-time doesn't just curve, it can also twist, thanks to the intrinsic spin of particles. At extremely high densities, like what you'd find at the core of a collapsing star, this twist might actually push back. Instead of collapsing into a singularity, the core might experience something called a big bounce, a rebound, like a trampoline snapping back from an intense impact. And that bounce, it could launch the birth of an entire new universe. So if that's what happened at the Big Bang, then maybe our universe wasn't born from nothing, but from the death of a star in another universe. Yeah. Let that sink in. This theory doesn't just tweak the story of cosmic origins. It completely flips it. Instead of a one-time bang, it paints a picture of an eternal, self-replicating chain of universes, each one born from the black holes of the last. And here's another curveball. Some scientists think the universe might even have a preferred axis, an invisible cosmic direction. Observations of galaxy clusters and large-scale structures show a weird alignment. Things aren't as randomly scattered as we expected. Why does that matter? Because in a universe born inside a black hole, a universe that rotated at birth, you might expect that kind of built-in directionality. A cosmic spin, if you will. Some scientists believe our universe may not be as uniform as we once thought. Something called cosmic anisotropy, meaning that the universe might actually have a preferred direction. And that throws a wrench into one of the bedrock assumptions of modern cosmology, the idea that the universe is isotropic and homogeneous, basically the same everywhere, in all directions, on a large scale. If that's not true, well, then something big might be going on behind the scenes. This preferred direction could be a clue, a whisper of unknown physics at play. Maybe it has something to do with the way our universe came into being, perhaps even inside a black hole. Or maybe it ties into how the fundamental forces of nature behave when stretched across the vastness of space and time. And it's not just the directionality. The existence of giant, fully formed galaxies showing up just a few 100 million years after the Big Bang is another major curveball. According to our current models, that kind of rapid galaxy growth shouldn't be possible. It's like finding a skyscraper in a town that hasn't even laid roads yet. But hold on, not every explanation has to be mind-blowing. There's also the possibility that we've simply made a mistake or two. Some astrophysicists suggest that maybe we've mismeasured things, like the rotational speed of our own Milky Way. If that's off, a lot of our calculations could shift with it. So before we rewrite the laws of physics or declare that we're all living in a black hole baby universe, we should make sure our instruments aren't just playing tricks on us. That said, whether it's exotic new physics or just a correction to the cosmic GPS, one thing's for sure. The universe is a whole lot stranger than we ever imagined. And those unexpected galactic spins, they've opened a door. One that'll force scientists to take another look at some of our deepest, most foundational assumptions about reality. But now, I want to hear your thoughts. Do you think we're inside a black hole? Or is it all just a case of cosmic miscalculation? Drop your theories in the comments. I'm reading all of them.